This is the K9 Thunder. Let's be clear. It doesn't have wings. It will never break the sound barrier, and its cockpit is a steel hull, not a glass canopy. But the name Thunder is no accident. This 47-ton beast is a king of the battlefield, a self-propelled howitzer so advanced it has captured a dominant share of the global market. It can unleash a storm of 3 shells in 15 seconds and vanish before the enemy even knows what hit them. It's a system born from one of the most intense strategic anxieties on the planet, and it has risen to become the quiet standard-bearer for modern artillery. So, how did this South Korean marvel, an underdog in a world dominated by Western arms giants, conquer the world of artillery? How did it become faster, more agile, and more sought after than its legendary American and German rivals? This isn't just a story about a big gun on tracks, it's a story about a nation's will to survive, a masterpiece of engineering, and a fundamental shift in how wars are fought and won. This is the complete guide to the K9 Thunder's devastating power, its battlefield-defining technology, and its unstoppable rise to global dominance. To understand the K9 Thunder, you have to understand the ground it was designed to defend. The Korean Peninsula, for all its modern energy, is technically a land still at war, defined by the 160-mile-long Demilitarized Zone, or DMZ. This is arguably the most heavily fortified border on Earth. And for decades, the strategic calculus of any conflict here has been dominated by one terrifying factor: artillery. In the late 1980s, the Republic of Korea Army faced a chilling reality. Across the DMZ, North Korea had amassed a gargantuan artillery force, thousands of guns dug into hardened, mountainous positions. Their doctrine was simple and brutal. If a conflict ever broke out, they would unleash a biblical storm of steel on Seoul, the South's sprawling capital, which sits perilously close to the border. This wasn't a theoretical threat. It was the central pillar of North Korean military strategy. South Korea's own artillery at the time was respectable, but it was aging. It was mostly made up of American M109 self-propelled howitzers from the 1960s and locally produced copies called the K-55. These weapons had served well, but they were from a different era. They were slower, had shorter ranges, and crucially, took way too long to get into position, fire, and move again. Against the North's overwhelming numbers and pre-sighted firing positions, a slow-moving gun wasn't just a liability, it was a death trap. The moment it fired, it would be swamped by counterbattery fire. The South Korean military knew it couldn't win a simple war of numbers. It had to be smarter, faster, and deadlier. It needed an artillery piece that could outrange its northern counterparts, deliver a devastating punch in seconds, and then disappear like a ghost before the enemy's return fire could land. Simply upgrading the M109s wasn't going to cut it. They needed a revolutionary leap, not an incremental step. This existential pressure was the crucible in which the K9 Thunder was forged. In 1989, South Korea's Agency for Defense Development, AD, and a group of companies led by Samsung Aerospace Industries, now Hanwha Aerospace, started an ambitious project. The goal wasn't just to build a new howitzer. It was to create a complete artillery system that solved the unique and terrifying challenges of the Korean DMZ. Researchers had been collecting data since 1983, convinced that future artillery battles would be defined by two things: burst fire and rapid relocation. The requirements were daunting. The new weapon had to handle the rugged, mountainous terrain of Korea with unheard-of speed. It needed a gun that could reach out and touch targets far beyond existing systems, and it had to be automated enough to execute its fire mission with terrifying speed. The development was painstaking, involving over 18,000 kilometers of driving tests and the firing of 12,000 rounds. By 1998, after nearly a decade of relentless work, the design was complete, achieving an impressive 87% localization of its parts. The first production K9 rolled off the line in December 1999 and was immediately deployed not to the Army, but to the Republic of Korea Marine Corps on Yeonpyeong Island, a sign of how urgent the threat felt in the most volatile border areas. This wasn't just another piece of military hardware. It was South Korea's answer to a 40-year-old nightmare. It was a declaration that they would no longer be held hostage by the threat of massed artillery. They had created a king, ready to claim its throne. The K9 Thunder isn't just one invention, it's a symphony of technologies working together to solve the critical problems of modern war. Its genius lies in how its parts create a system far greater than their sum. To really get why the K9 dominates the global market, we need to break down its core elements: its devastating firepower, its ghostly survival tactics, its mind-bending steel rain capability, and the raw power that gives it unmatched mobility. At the heart of the K9 is its main weapon, the CN98 155mm 52 caliber cannon. Let's break that down. 155mm is the diameter of the shell, a NATO standard that allows it to use ammunition from allied nations, a huge logistical advantage. But the key number here is 52 caliber. In artillery, caliber describes the barrel's length as a multiple of its diameter. The K9's barrel is 52 times 155mm, which comes out to a staggering 8.06 meters long. This immense length is the secret to the K9's incredible range and power. A longer barrel allows the explosive gases to push the projectile for a longer time, resulting in a higher muzzle velocity. While older howitzers like the M109 Paladin used shorter 39 caliber barrels, the K9's 52 caliber design puts it in a whole different league. With standard high explosive ammo, the K9 can hit targets 30 kilometers away. When it uses more advanced ammo, like rocket-assisted projectiles, RAP, or shells with a base bleed unit to reduce drag, its reach extends to over 40 kilometers. Recent developments with specialized rounds are pushing this even further, with some tests reaching 54 to 60 kilometers, effectively doubling the engagement distance of older systems. This means a K9 can sit comfortably outside the range of most enemy artillery and strike with impunity. But range is only half the story. The other half is the rate of fire. This is where the K9's design philosophy of ruthless efficiency shines. The K9 is capable of an astonishing burst rate, 3 rounds in just 15 seconds. This first volley is designed to inflict maximum shock and damage before the enemy can react. After this burst, it can sustain a high rate of 6 to 8 rounds per minute for 3 minutes, before settling into a sustained rate of 2 to 3 rounds per minute. This is all possible thanks to a semi-automatic loading system. While a human loader still places the propellant charges, the heavy 45 kilogram shells are handled by an automated feed, which drastically reduces crew fatigue and keeps the firing tempo high. In modern artillery warfare, the deadliest threat to a howitzer is another howitzer. The moment a gun fires, its position is betrayed. Acoustic sensors hear the blast, and counterbattery radars track the shell's trajectory back to its origin. Within minutes, sometimes seconds, retaliatory fire is coming. To survive, a howitzer cannot be where it was when it fired. This is the doctrine of shoot and scoot, and it is the absolute cornerstone of the K9's design. The K9 Thunder is a master of this deadly dance. Its entire system is optimized for speed. From a dead stop, the K9 can halt, deploy its stabilization systems, and fire its first round in an incredible 30 seconds. This speed is achieved through a suite of advanced tech. The K9 has an automated fire control system, an inertial navigation system, INS, and a GPS. The crew doesn't need to get out and do manual surveys. They get target coordinates digitally. The onboard computer instantly calculates the firing solution, and the turret automatically swings into position. The gunner confirms, and the weapon fires. The moment the last shell leaves the barrel, the scoot phase begins. The crew can have the vehicle packed up and moving in as little as 30 to 60 seconds. The K9 is gone from its firing position before its own shells even hit a target 40 kilometers away. By the time enemy radar gets a lock and directs return fire, the K9 has vanished, leaving only an echo of its thunder. This ability to appear, strike, and disappear makes it a ghost on the battlefield, a phantom that hits like a hammer and can never be pinned down. If shoot and scoot is the K9's key survival skill, its most famous offensive capability is multiple round simultaneous impact, or MRSI. It's a feature that sounds like science fiction, but it's a very real and devastatingly effective tactic. MRSI allows a single K9 to fire multiple shells, usually 3, that all land on the same target at the exact same time. How is that possible? It's a brilliant application of physics. The K9's fire control computer orchestrates the whole thing. The first round is fired at a very high trajectory, like a mortar, giving it the longest flight time. Immediately after, the barrel is lowered, and the second round is fired on a flatter, faster trajectory. Finally, the barrel is lowered again for the third round, which follows the flattest, fastest path with the shortest flight time. Even though they're fired seconds apart, their different paths mean they travel for different amounts of time. The computer calculates these differences perfectly, timing each shot so all 3 projectiles converge on the target at the same instant. The effect on the receiving end is catastrophic. Instead of the 1, 2, 3 sequence of explosions that might give soldiers a second to dive for cover, the target is hit by what feels like a full artillery battery strike in a single, earth-shattering moment. It maximizes shock, confusion, and lethality. This ability for one K9 to have the effect of 3 makes it an incredibly efficient force multiplier. A howitzer's firepower is useless if it can't get to the right place at the right time. The K9's ability to shoot and scoot is entirely dependent on its mobility. At the core of its agility is a titan of an engine. The German-designed MTU MT881 KO 500, which produces a colossal 1,000 horsepower. When you combine that power with the K9's 47-ton weight, you get a power-to-weight ratio that rivals many modern battle tanks. This gives the K9 startling speed. On roads, it can hit 67 kilometers per hour, allowing it to keep pace with tanks and mechanized infantry. Its operational range is around 360 kilometers on a single tank of fuel, significantly farther than its American M109 counterpart. But the K9 was born to operate in the punishing, mountainous terrain of Korea. To conquer this landscape, it was fitted with an advanced high-drop pneumatic suspension system. This isn't your car's suspension. It's a sophisticated setup that actively manages ride height and stability. It allows the K9 to glide over rough ground, from the snowy forests of Finland to the arid deserts of Egypt. It can cross trenches nearly 3 meters wide and climb steep 60% gradients. This combination of a powerful engine and an intelligent suspension gives the K9 the tactical mobility to go almost anywhere a tank can. It isn't confined to roads. It can navigate the battlefield with an agility that belies its massive size, ensuring its devastating firepower can be brought to bear exactly where it's needed most. The K9 Thunder didn't emerge in a vacuum. It entered a market dominated by two titans, the American M109 Paladin, the most common self-propelled howitzer in the West, and the German Howitzer 2000 or PESH 2000, often seen as the technological benchmark. The K9's global success comes from its ability to outperform the M109 and offer a better value than the PESH 2000. It found the sweet spot of performance, cost, and reliability that has made it the weapon of choice for a growing list of nations. Comparing the K9 to the M109 Paladin is like comparing a modern smartphone to an early 2000s flip phone. While both do the same basic job, one is a complete generational leap. The M109 series started in the 1960s and, despite upgrades, is still limited by its original design. First, range and firepower. The latest M109 A7 variants use a 39 caliber barrel, giving them a max range of about 30 kilometers with assisted projectiles. The K9, with its 52 caliber gun, starts at 40 kilometers and goes up from there. That's not a small difference. It's a huge tactical advantage. The K9 can engage an M109 from a distance where it simply can't fire back. Next, mobility. Despite being heavier, the K9 is substantially faster. Its 1,000 horsepower engine gives it a top speed of 67 kilometers per hour, easily beating the Paladin's 56 kilometers per hour. The K9's operational range of around 360 kilometers also outpaces the Paladin. This means the K9 can travel further and faster, keeping up with modern armored units more effectively. But the most critical difference is shoot and scoot. The K9's ability to be ready to fire in 30 seconds and move out just as quickly is a game changer for crew survival in a modern war zone. The M109, being an older design, simply can't match that tempo. For nations looking to modernize their artillery, the K9 offers a quantum leap in every key metric over the aging Paladin. The fight between the K9 Thunder and the German PESH 2000 is much closer. Both are 155mm per 52 caliber systems developed in the same era and are considered the gold standard. They share similar performance and even use the same powerful MTU 881 engine. The differences are more about design philosophy, automation, and most importantly, cost. The PESH 2000 has a key advantage in one area: its fully automated loading system for both the shell and the propellant charges. This gives it a slightly faster burst rate, 3 rounds in 9 seconds, and a blistering sustained rate of 10 rounds per minute. It also carries more ammo on board, 60 rounds to the K9's 48. However, that advanced automation comes at a very steep price. The PESH 2000 is significantly more expensive than the K9 Thunder, with some estimates putting it at double the cost or more. It's also heavier, tipping the scales at over 55 tons, which can affect its strategic transport options. This is where Hanwha's strategy with the K9 proved brilliant. They made a system that delivers 90 to 95% of the PESH 2000's performance at a fraction of the cost. For many countries, the slight increase in fire rate offered by the German machine doesn't justify the huge leap in price. Furthermore, South Korea's defense industry has earned a reputation for rapid production and delivery. In a world of rising tensions, getting equipment to soldiers quickly is a major selling point. Hanwha has proven it can fulfill massive orders, like Poland's contract for hundreds of units, on a timeline that many European manufacturers would struggle to match. Ultimately, while the PESH 2000 might be the slightly more advanced machine on paper, the K9 has proven to be the smarter purchase. It offers comparable range, mobility, and survivability in a package that is more cost-effective and easier to get in large numbers. A king doesn't rule alone, and the K9's effectiveness is magnified by its silent partner, the K10 Ammunition Resupply Vehicle, ARV. The K10 is more than just a truck that carries shells. It is the world's first fully automated robotic ammunition carrier, designed to work in perfect harmony with the K9. The problem with a howitzer that fires as fast as the K9 is that it burns through ammunition. In older systems, resupplying is a slow, laborious, and incredibly dangerous process where crew members have to haul heavy shells by hand, exposing themselves to enemy fire. The K10 eliminates this vulnerability. It's built on the exact same chassis as the K9, uses the same engine, and has the same armor protection. This commonality is a logistical masterstroke, simplifying maintenance and ensuring the K10 can keep up with the K9s anywhere. But its true genius is its automated transfer system. A K10 carries 104 shells and hundreds of propellant charges. When a K9 needs to reload, the K10 simply backs up to it, and a connector bridge extends to dock with the K9's turret. Once linked, a robotic arm transfers shells directly into the K9's magazine at a blistering rate of 12 rounds per minute. The entire operation is controlled by the crew from inside the safety of their armored cabins. A K9 can be fully reloaded in minutes, ready to get back into the fight. This turns the K9-K10 pair into a self-sustaining fire factory, able to maintain a relentless pace of operations. The K10 is the unseen linchpin that makes the K9's sustained reign of thunder possible. The ultimate proof of a weapon's success is the number of nations that bet their security on its performance. By this measure, the K9 Thunder is a global phenomenon. It has achieved a dominant share of the global self-propelled howitzer market, a staggering achievement for a nation once considered a secondary player in the arms industry. The list of countries in the K9 Users Club reads like a tour of the world's geopolitical hotspots. The first export customer was Turkey, which licensed the design for its T-155 Fırtına Storm. Then came a wave of adoption from nations wary of a resurgent Russia. Finland, Norway, and Estonia all chose the K9 to replace their aging artillery, valuing its reliability in their challenging northern climates. Poland represents the K9's most spectacular success. After the 2022 conflict in Ukraine, Warsaw signed a massive framework agreement for hundreds of K9 howitzers. The deal was driven by the K9's proven performance and Hanwha's ability to deliver the systems with incredible speed. Recently, Romania followed suit, becoming the 10th country to buy the K9 with a $1 billion deal for 54 units, solidifying its position as a de facto standard in Eastern Europe. Further afield, India procured a specialized version, the K9 Vajra T, adapted for high-altitude operations along its border with China. Australia also chose the K9, locally designated the AS9 Huntsman, for its army. Egypt became the K9's first customer in Africa and the Middle East, signing a $1.7 billion contract after it beat out top competitors. This global expansion is a testament to the K9's core strengths, a perfect balance of performance, reliability, and cost. It shows that South Korea has created not just a weapon, but a trusted platform that is shaping the future of artillery forces around the world. For over a decade after its introduction, the K9's reputation was built on specs and exercises. But on November 23, 2010, its capabilities were put to the ultimate test in actual combat. On that day, North Korea launched an unprovoked artillery barrage against the South Korean island of Yeonpyeong, where a battery of 6 K9 Thunders was stationed. The attack was sudden and intense, with around 170 shells raining down, causing casualties and damage. The K9 battery immediately prepared to respond, but the situation was far from perfect. The initial bombardment had been effective. 2 of the 6 K9s had their electronic fire control systems damaged by the shock of nearby impacts. A third K9 had its barrel temporarily jammed by a dud shell. Despite the chaos and damage, the 3 remaining operational K9s unleashed a furious counter-barrage. They fired a total of 80 shells back at the North Korean positions on the mainland. Initially targeting barracks, they later shifted fire to the enemy's artillery positions once they were identified. This was the first artillery battle between the two Koreas in decades. The aftermath was a sober lesson. The incident highlighted the vulnerability of even advanced systems to a surprise attack, leading to immediate improvements in the K9's armor and the construction of hardened shelters. But it also proved, under the most intense pressure imaginable, that the K9 worked. The crews, though under direct fire, were able to effectively return fire. The K9 had faced its baptism by fire and proven itself to be a resilient and deadly combat system. The K9 was never meant to be a static design. Its creators saw it as an evolutionary system, constantly adapting to new technologies. The first major evolution was the K9A1, which is now the standard for the ROK Army. It received an improved fire control system and, critically, a new auxiliary power unit, APU. The APU allows the K9 to operate its electronics and turret without running the main 1000 horsepower engine, reducing its heat and noise signature and making it even harder to detect. The next step, now in advanced development, is the K9A2. This version marks a significant leap toward automation. The key upgrade is a fully automated shell and charge loading system, which Hanwha aims to complete development of in the near future. This will boost the rate of fire to over 9 rounds per minute and reduce the crew from 5 down to just 3. But the most dramatic evolution is still a concept, the K9A3. This is where the platform moves from being automated to potentially being autonomous. Conceptual designs for the K9A3 showcase a system that could be operated completely unmanned, sent into a high-risk area, and controlled remotely. The K9A3 is also set to get a massive firepower upgrade with a new 58 caliber barrel. This longer barrel is projected to push the K9's maximum range to an incredible 80 kilometers with advanced ammunition. With a single operator or full autonomy, a remote weapon station for self-defense, and an 80 kilometers reach, the K9A3 represents a philosophical shift, transforming the Howitzer from a gun on tracks into a semi-autonomous node in a larger firepower network. The K9 Thunder has proven itself a dominant force, but military technology never stands still. Its closest rival, the German PZH-2000, already has a fully automatic loader, while future American programs promise even longer ranges. So, the question remains, is the K9's blend of affordability, reliability, and rapid evolution enough to keep it on top for the next decade, or will a more expensive, more advanced competitor eventually reclaim the throne? Let us know your thoughts in the comments below. From its origins as a desperate answer to an existential threat, the K9 Thunder has journeyed to the pinnacle of global artillery. It's the story of a nation that refused to be outgunned and instead chose to outthink, outmaneuver, and out-innovate its rivals. It is not just a collection of impressive specs. Its 40-kilometer range isn't just a number, it is a zone of safety for its crew and a bubble of lethality for its enemies. Its shoot and scoot capability isn't just a tactic, it is a doctrine of survival, perfected to a 30-second art form. And its MRSI steel rain isn't just a technical trick, it is the physical manifestation of overwhelming shock and awe delivered from a single, unseen platform. The K9 Thunder found the perfect balance between devastating performance, rugged reliability, and pragmatic cost. It proved you don't have to be the most expensive to be the best choice. Through constant evolution, from the battle-hardened original to the automated K9A2 and the autonomous concepts of the K9A3, it has cemented its legacy as a living platform that defines the cutting edge. It may not have wings, but the K9 has soared to the top of the world's arms market. It doesn't break the sound barrier, but its impact on the modern battlefield has been just as explosive. It is, and for the foreseeable future will remain, the undisputed king of the battlefield, a rolling storm of South Korean thunder that has truly conquered the world.